Hello secondary one, this is Mr. Hafidi, one of the Farouk Language School, and today inshallah we'll start a new video, equation of a straight line, vector. So we have direction vector of a straight line. Every non-zero vector can be represented by a directed line segment on a straight line. It's called a direction vector of the straight line L. So we have the straight line L and we have A and B and C belong to the straight line L. So we can represent the direction vector of the straight line L by AB directed line segment, BC directed line segment, and CA directed line segment are direction vectors of the straight line. For example, if u equal to and 1 is a direction vector of a straight line L. So each of vectors 4 and 2, negative 2 and negative 1, 1 and 1 over 2 represent the direction vectors to the straight line L. Because 2 and 1 we can multiply by scalar like 2, so will be 4 and 2, or multiply by negative 1, so will be negative 2 and negative 1, or multiply by half, so will be 1 and 1 over 2, is a direction vector of this line. In general, if u equal a and b, ordered pair a and b is a direction vector to a straight line, then k time u vector, where k belong to R except 0, is a direction vector to the same straight line. As we said before, in vectors we can represent any vector by an infinite number of vectors parallel to this vector by multiply this vector by a scalar quantity like k, and k belong to R except 0. If u vector is 2 and negative 3 is a direction vector to a straight line, then which of the following is a direction vector to the same straight line? So we have u multiply k. To find the direction vectors are equivalent to u, so we can multiply u by scalar which is k. So in first one, k here is equal to negative 1, because we multiply 2 by negative 1 will be negative 2, and negative 3 multiplied by negative 1 will be 3. So negative 2 and 3 represent direction vector to the same straight line. Direction vector to the same straight line. Second one, negative 2 and negative 3. So negative 2, so it means we multiply 2 by negative 1. So we must multiply negative 3 by same scalar, which is negative 1. So will be 3. So this is negative 3. So negative 2 and negative 3 doesn't represent a direction vector to the same straight line. The third one, letter C, 2 and 3. If we multiply negative 3 by negative 1 to be 3, so we must multiply 2 by same scalar, which is negative 1. So its mean will be negative 2, not 2. So this is doesn't represent a direction vector to the same straight line. The last one here, 6, its mean we multiply 2 by 3, so k here is 3. So if we multiply 3 by 2, so multiply negative 3 by 3 will be negative 9. So represent a direction vector to the same straight line, and k here equal 3. Now we will explain equation of the straight line given a point belonging to it and a direction vector. So first, vector form, determine the equation of the straight line passing it through the point E, and the vector u is the direction vector to it. So if we have straight line L and we have A belong to the straight line, and we have the direction u is parallel to the straight line L. So let the point B belong to the straight line L. P represents any point on a straight line L. So P in general represents any point on the straight line L. So now we'll take the direction from O, from the origin point to A, by the vector A, and from O to the point B by the vector R. So the vector R and A represents the two directed line segments OP and OA respectively. So where O is the point of any point in the plane. Then there are number k belong to R except 0, the scalar quantity. So we have a p equal k time u, because u vector is represented by straight line parallel to the straight line L. So vector or directed line segment AP equal k time u. So we can write AB as OB by subtraction rule. OB minus OA equals k time u vector. So if you want to find OB as a vector represented by R and OA represented by vector A, so R vector minus A vector equal k time u vector. So R vector equal A vector plus k u, and this form is called the vector form. And the vector equation of the straight line L which passes through the point A and U is the direction vector. This form is called the vector equation of the straight line L which passes through the point A and U is the direction vector. And this form represents the set of points on a line passing through the point A and parallel to U vector. So we have the form of vector equation R vector equal A vector plus k U vector. So we have example, find the vector equation of the straight line F. It passes through the point 2 and the negative 3, so 2 and the negative 3 represent the vector A, and the direction which is represented by U vector, which is 1 and 2. So the vector equation will be R equal A, which is represented by 2 and the negative 3, plus K multiplied by the direction which is represented by 1 and 2. Another example, we have a vector equation which is a straight line passes through the point negative 3 and 5. So A represents the point in negative 3 and 5 perpendicular to the direction vector. So perpendicular to the direction vector, so the direction vector U will be 2 and 1. Okay, so the required form will be R equal negative 3 and 5 plus K multiply U vector, which is represented by 2 and 1. So this is called vector 4. Let's through the 2 points 2 and the negative 3 and the m and 1 and 5 and 1. So we can find the slope from the 2 points by using the rule y2 minus y1, which is 1 minus negative 3, 1 plus 3 over 5 minus 2. So it will be 4 over 3. So we can expect the direction vector, which is u, which is represented by 3 and 4. So we have the required form R equal A plus K multiply U vector. So R equal A, which is represented by any point, so 2 and the negative 3, plus K multiplies the direction vector 3 and 4. And number 4 passes through the points 2 and the negative 1 and the slope 1 over 2. So the direction vector U will be 2 and 1, and the point A represented by 2 and the negative 1. So R equal 2 and the negative 1 plus 2 plus K multiply 2 and 1. Passes through the point 3 and 1 and it makes 30 degrees with positive direction of x-axis, so we can find the slope of the straight line by using tan the angle, which is 30. So m equal tan 30, which is equal 1 over root 3. So the u direction will be root 3 and 1. So we can write the form R equal A plus K multiply U, and we have A represented by the point 3 and 1. So R equal 3 and 1 plus K multiply root 3 and 1. And pass through the point negative 1 and 4 and parallel to the straight line x plus y equals 7. So the slope of the given straight line, the slope of the given straight line, which is represented by m1, can say m1, so negative coefficient of x over coefficient of y, so will be negative 1 over 1, which is mean negative 1. So m2, the required slope will be also negative 1 because the two straight lines are parallel. So can write the u vector as we have negative 1 over 1, so will be 1 and negative 1. So the required and the point A represented by negative 1 and 4. So the required equation are equal A plus K multiplied by U vector. So R vector represented by A, which is negative 1 and 4, multiply plus K multiplied by the vector U, which is represented by 1 and negative 1. So this form is the required form, which is vector form. Passes through the point 5 and 7 and parallel to the line whose vector equation are equal to and 3 plus k multiply negative 1 and 4. So negative 1 and 4 represent the direction of the direction vector of the given straight line will be negative 1 and 4. So the required vector or the required direction vector will be also negative 1 and 4. And we have the point which is represented by A, 5 and 7. So we can write the equation are equal 5 and 7 plus k multiplied by the u vector, which is represented by negative 1 and 4. And we have passes through the point 2 and 3 parallel to x-axis. Parallel to x-axis, its mean m equal slope of the required equation equal 0. 0 its mean u vector will be 1 and 0. So we have A equal 2 and 3. So the required equation will be A plus k multiplied by the direction u or u direction. So R will equal A, which is represented by 2 and 3, plus k multiply the vector u, which is represented by 1 and 0. So the required form or the vector form will be R equal to and 3 plus k multiplied by 1 and 0. So we have passed through the straight line through the negative 3 and 0. So this represents by a vector equal negative 3 and 0 perpendicular to line 2x minus 3y equal 1. So we have m1 will equal negative coefficient of x will be negative 2 over coefficient of y negative 3, so will be 2 over 3. So the required slope will be m2 will be negative 3 over 2. So the direction vector u will be 2 and negative 3. So we can write R equal A plus K multiplied by U vector. So R equal negative 3 and 0 plus K multiplied by U vector, which is represented by 2 and negative 3. And this form is called vector 4. This is through the point 2 and 3 and perpendicular to x-axis. Perpendicular to x-axis, its mean parallel to y-axis, its mean its slope is undefined. So m equal 1 over 0. So we can write the direction vector as 0 and 1. And we have the point A represented by 2 and 3. So R equal 2 and 3 plus k multiply u vector which is represented by 0 and 1, and this is the vector passes through the midpoint of AB and perpendicular to it. So we can find the slope of the straight line AB by make the rule 1 minus negative 3 over 3 minus 1. So it will be 4 over 2, which is 2. So the required slope will be negative 1 over 2. So the direction vector will be 2 and negative 1. And the midpoint of AB, which is represent the vector A, will equal 1 plus 3 over 2 and negative 3 plus 1 over 2. So 1 plus 3 will be 4 over 2 will be 2, and negative 2 over 2 will be negative 1. So R will be A plus K multiply U. So R will be A, which is represented by 2 and negative 1, plus K multiply the U vector, which is also 2 and negative 1. Number 12, passes through the point A, 1 and negative 3, and perpendicular to CB, where C equals 3 and 0, B equal negative 5 and 1. So we have A vector will be 1 and negative 3, and M1, which represents the slope of the given straight line, which is CB, by using the rule 1 minus 0 over negative 5 minus 3. So will be 1 over negative 8. So the required slope M2 will be positive 8. So the direction vector will be 1 and 8, because 8 over 1. So will be 1 and 8. So the vector form will be A vector plus K multiply U vector. So R equal A, which represented by 1 and negative 3, plus K multiply the vector U, which is represented by 1 and 8. Thank you for listening, and see you in the next video, inshallah.